Are you struggling with executing business logic in a separate thread pool using Netty? You're not alone. This is a common challenge for many developers. Today, we will explore how to effectively manage your thread pools to keep your I/O event loop running smoothly. I understand how frustrating it can be when your business logic seems to block the I/O event loop, especially when you expect it to run asynchronously. Many developers face this issue, and it can be quite perplexing. Let's dive into the specific question at hand. One user asked, "Why is my business logic still executing synchronously, even after adding default event executor group to the pipeline?" This is a great question, and one that deserves a thorough look. To understand the issue, you need to look at how Netty handles threading. The default event executor group is designed to execute tasks in a separate thread pool, but there are specific ways to ensure that your handlers utilize this feature correctly. Stay with me. By the end of this video, you'll have a clear understanding of how to implement your business logic in a separate thread pool effectively. To ensure that the business logic executes in a separate thread pool, the user should first confirm that the default event executor group is correctly added to the pipeline. This allows the handler to run in a different thread from the I/O event loop. Next, the user should check the implementation of the server handler. The channel read 0 method should not block the thread. Instead of using thread.sleep, the user can utilize a completable future to run the blocking logic asynchronously. Additionally, the user should ensure that the business logic does not return a response until the processing is complete. This can be achieved by using a callback or a future to handle the response after the logic has finished executing. Finally, the user should test the implementation to confirm that the business logic is now executing asynchronously. They can do this by observing the console output to ensure that multiple requests do not block each other. Fun fact, did you know that the concept of multi-threading dates back to the 1960s? It's amazing how far we've come in managing concurrent processes. Now let's look at the answers provided by other users. This user points out that Netty handles requests from the same socket using the same event executor. To see the business logic executed in parallel, you can start multiple clients. Here's a pro tip. Always test your handlers in isolation to ensure they are functioning as expected before integrating them into your main application. This can save you a lot of debugging time. And there you have it. With these steps, you should be able to execute your business logic in a separate thread pool successfully. If you found this video helpful, please subscribe for more tips and tricks on Netty and other programming topics.